Hey guys, it's me, Avi from Team 1961Z, and I'm sorry for not posting in a long time, but hopefully now I can start posting again every week or so. So today, what's my plans on teaching today is basically I'm going to be teaching on how to debug, so basically using the terminal to see what's actually happening to the robot during the 15 seconds of autonomous period, and also teach you guys the basics of turn without PID. So yeah, let's get started. Let me get ready for the robot. Let's hit download. So now I'm going to download this program to the robot. Now I'm going to run the robot. As you guys can see, the robot is moving and I can go 24 inches. So that's good. But do we actually know that the robot goes 24 inches? Question. What if it's actually not? So the way to see that the robot's actually going 24 inches is through debugging. So debugging utilizes the features of this terminal. So the terminal basically right here, so basically the data would appear in every single line. It would say, okay, here's what's happening in this motor, what's happening in this motor, what's happening in this motor. And so the way to do this is we have to create something called a task. So the way to create a task is basically why do we have to create a task is because this move forward function is something called a synchronous function. So a synchronous function basically means that only that function can happen during that time. So once that function's done, then it moves on to the next set of code. But that's an issue because how else are we supposed to look at the code? Or not the code, basically how are we supposed to look at the data that's constantly looping in the background? So the way to do that is we do something with a task. A task basically is something like a asynchronous function. Asynchronous function basically means that you can have two things simultaneously running without them interfering into each other or causing them to be blocked. So the way to do that is basically via tasks. So, and I'll go in more in depth into tasks when I start talking about how to make macros, what are macros. But for now, this is a very simple understanding of how tasks works. So let's just get started with creating this. So it's very simple. What we do is we do int, and we're going to call this debugging, and we're going to call this as a void function. Debugging, and now I'm going to go to Untitled Function CPP. We're going to do int debugging, and then we're going to do a while loop. I'm going to have a while true statement in here. This is a very simple way of how you set up a task. And so inside of this while true statement, we're going to have a printf statement. And so this printf is basically what allows us to print this data to the terminal. So the way to do that is we do distance traveled in by left front. And then we're going to do comma. Oh, one more thing. You want to do %f. So the %f is basically telling that the C compiler that this is going to be a float data type. And there are multiple variations like I, so I stands for integer, but for now, because we're using a double, we can use %f. And the /n basically means a new line after that. And then what we're going to do is we're going to do front left dot get dot rotation, and we're going to do press or degrees. And then do that. And now let's say I downloaded compile, but there's a big issue. The issue is that degrees is a very useless number to us humans. We can't really interpret degrees. It's a very broad number. So the way, basically a better way to do this is through converting this degrees that you're getting and turning it into inches. So the way to do that is basically we're going to rearrange our this formula that we had for degrees to calculate degrees to rotate with our distance, but now we're trying to find distance. So the way to do that is basically I'm going to take our circumference, and we have this here, and basically on this robot, it's a 4-inch wheel with a 3 to 7 gear ratio. That's why we have this constant 0.4287143. So that's basically I did 3 divided by 7 due to the gear ratio. So now what we're going to do is we're going to say distance traveled by left front in inches. And we're going to say front left dot rotation degrees. So what we do is now that we say this is, so front left dot rotation degrees is basically this. So that means we're going to multiply this by circumference. And then divide this by 360. And this will give us the inches that the motor has traveled. So now we're just going to copy this. And fix this indentation. And now we can change this to left, right. Left back. Now we can change this to front, right, back, left, and back, right. But there's still one more thing that we need to do, and that's basically we're going to have to put this as a task, and then we're going to sleep this for 10 milliseconds. And the reason that we have to sleep this task for 10 milliseconds is basically because that's how much time it takes for the motors to process the data and send it to the brain. So this is a very necessary sleep function. So now what we're going to do is we want to initialize this task. So the way to do that is you're going to go to in main CPP, we're going to say task debugger. What is task debugger? And now when I download, it should properly compile. And now it downloads the robot. So now what I do is basically I'm going to open up the terminal. So here's the terminal, and I'm going to run my program. So once I run my program, then you guys will see all of this data. Now, I'm going to turn off the program. You guys can see that it's telling me how many inches it has traveled, and it's basically almost 24 inches, which is really good for something that is not PID and all of the complicated control systems. So now that we have debugging out of the way and we can see that forward and backward functions work properly, we can start moving on to left and right functions. So let's get started. Let's clear this. Alright, and this problem will go away soon. Alright, so let's do this. Alright, so we're going to go to autofunctions.h again, and we're going to create a simple like we did for our move forward function. We're gonna have a void turn left crawl, and then we're gonna call it one parameter because this is our crawl function with speed. And then let's go here into auton functions and let's create that function. Void turn left crawl with our parameter as speed. So this is a very simple function. So basically what we're only going to do is turn left infinitely. So what we're going to do is we're going to do front left dot spin forward negative 100 speed version at negative speed percent. Because we're using. So now I'm going to copy this. Paste this 4 times, and so the theory behind this is basically to do point turns, you want the left side to go in reverse and the right side to go forwards, and vice versa for right side. So that means when you're trying to turn right, that means the right motors are going to spin the backwards direction and the left motors are going to spin the forward direction. So when we make this front right, I'm going to make this positive speed. I'm going to make this back right. Make this positive speed as well, and I'm going to change this back left. Now, I'm going to go to main CPP, and I don't really want these right now because I'm going to try to debug, and I'm just going to say turn left with 50 speed. So, and let's say I download it. Now that it's downloaded, I'm going to go and run the program. Let's see what happens. As you can see, it turns left continuously. So let's run the program. And now that we got a turn left function, now I can create a very simple turn right function as well. So we're going to just do this basically what we did for turn left. We're going to do turn right, crawl, and now basically we can just copy this, paste this, turn right, crawl, and instead now we're going to flip these. So these are positive, this is negative, this is positive, and this is negative. Now, if we cross this out, or comment it out, sorry, and we say turn right, crawl at 50 speed, download this to our robot. Now we run this program on the robot. You can see now it turns right, and it continues to turn right. Now let's move on to the next part. So now we want to say, okay, that's great, but how do we say, all right, I need this robot to turn towards the goal, which is 30 degrees. So what we're going to do is now we're going to create another function. Now we're going to say, all right, let's move on to our walk, our next progress. We're going to do void turn left walk. And now we're going to have two parameters, so in speed obviously, and the next parameter I'll make it as double in case you want to do double, like 45.5 degrees, but we're going to call this degrees to turn. And let's go to functions.cpp and let's create that. So void turn left walk, so in speed as one of the parameters, and double for the other parameter for degrees to turn. Now we can start working on this. So basically the concept of this is basically the same as the concept of how the forward and backward functions work. So the way to do this is basically we're going to say is we're going to have these rotate for functions, but we're not going to use really the inches or the circumference. So this technique I actually learned from one of the videos that I was actually watching when I was trying to learn how to code, and a VexCode team called Aura actually implemented this into their robot, and this is how they calculated how many degrees to turn. So what they did was kind of smart. So what they did was they had this function. So what they did was an operator control. They basically turned the robot in 360 for 10 times and took the average of the ticks that the motor runs. So basically what they did was they said printf, so that printf function that we had created, this printf function, we can basically copy this. What they did was, and for this we don't really need a test because it's already in a while loop, so it's always going to be repeating. So distance traveled by left front, and since we don't really want this in inches, we want to keep this in degrees because this is what we're going to take. So we're going to take this away. And because it's not in inches, we can get rid of these times circumference and all of that. And once we get rid of these errors, when we download this basically, and let's say I run the program on my robot, and oops, let me go forward a little bit. So now, a little bit forward, I reset the program, and I get rid of this, and now I'm basically gonna just turn 360. For just the sake of timing for the video, we're just gonna do one turn, and basically from this turn we can see that our value is pretty close to 2200. So what we're gonna do now is we're gonna have this integer variable. We're gonna call this int ticks. So this is the amount of ticks that it takes for our robot, so the motors to do for a full 360. So we're gonna do 2200. So now, what we're going to do is we're going to say, alright, cool, now that we know that, we're going to say, alright, from our ticks, how do we figure out, okay, this is how many ticks it's going to take for us to turn 45 degrees. And it's very simple. What you're going to do is we're going to have a double, we're going to call this ticks to turn. Now, we're going to have this equal to degrees to turn times our tick value, divide this by 360. So basically what this does is, now that we have 45, let's say we do 45 times the ticks, and then we're going to divide it by 360 to figure out how many ticks it takes for us to turn 45 degrees. And now we're basically just going to say, alright, that's cool. Let's take this front left, front right rotate. Now, I'm just going to copy and paste that into here. Instead of degrees to rotate, it's going to be ticks to turn. Ticks to turn. Ticks to turn. Now, because as I said before, when we want to turn left, that means our left motors have to go in the reverse direction and the right motors have to go into the forward direction. To make sure that that happens, what we're going to do is we're going to change the front left ticks revs into negatives and keep the front rights, the right side to positive. And now let's download this to our robot, and let's call this our main CPP function. Let's get rid of this. Let's say turn left walk. Let's say we go at 30 speed, and let's say 90 degrees. So now, when we compile and download this to our robot, it should hopefully turn 90 degrees. Program on the robot. As you guys can see, now has turned 90 degrees. So that's how we do for left turns. So now the same thing is for right turns. Now we can say void, and just copy this, we just say OV, we're going to say turn right. And then we're going to say this is degrees to turn. Now we're going to go to src, operator, not on functions. Now we're going to copy this basically. Turn right. Turn right. Now we're going to basically say, because this is different, now we're going to do front right, go in the negative direction, and left goes in the right direction. Now we can go to main CPP, so turn right, walk, we can say 30, and 90, and now we can now test, or, hold on. This is a building error. Why are we getting an error? Oh. Turn right, walk. Make sure I did this right here. Alright, cool. And now I'm going to download. And one more thing, because we want this to stop after a little while, so we're going to have a test sleep function in between these two, so they don't happen one after the other and give some break. Test sleep for about, we can say 1 milliseconds. And we're going to download now to the robot. And it's running on the robot. Left 90, now change right 90, and now it's perfectly from where it started. And it's not obviously that perfect right now because we have no PID or anything running on that. It's just a simple, very simple function of turn left, turn right. And into later videos, when we get more complicated, I'll teach you guys on how to make control systems and how PID works. But for now, this is very simple turn left, turn right functions, and also with debugging involved. So I hope you guys like this video, and as usual, if you guys have any questions, feel free to ask me in the comment section, and I'll gladly love to help you guys out with any of the problems you're experiencing. And if you have even more complicated questions about something we haven't learned yet, I'll still gladly love to help you guys. Thanks guys, I'll see you guys next week. Bye.